And now I'm going to share my screen. And let's see, I'm going to hide the video panel. And see if there's anything else I need to do. I'm going to bring up what we're going to talk about. The first thing I was going to talk about was test 4. Test 4 was not as good as test 1 and 2, although we did have a lot of students do well on it. The median was only 67 of the class. I think last time we had a median of about 80. In fact, first quartile was 50, which meant that 25% of the students made an F. And I'm a little concerned about that. I hope that those who didn't do well will at least watch this video and let me know what they want me to help them with. I thought I would go over briefly some of the things that people had a problem with on the test. There was one question that I thought nobody should have missed that relates to a relationship between two quantities on a function. It's where every input, which is an x, has only one output. And I would say 50% is this. And that was all in the notes. Finding the equation for a linear function between 2 points. I'm not going to work this because it's all in the notes, but everybody should have been able to calculate the slope of that line. Which is minus 2/3. And then use the formula y minus y1 m times x minus x1. And I won't finish it. But anybody who missed this needs to go and redo it. Another simple linear problem about a guy stuffing envelopes. He already had stuffed 14, so that's what he had when he started. And he'll continue to stuff 7 every minute. Find a linear function e of t that represents the total number of envelopes he'll have stuffed in t minutes. Well, that's just going to be, slope is going to be 7 times t plus how much he started with. And that's the simple answer. And I'm afraid that a number of students miss that one. Population of a town decreasing at a rate of 1.5% per year. That is an exponential function, not a linear function. A number thought it was linear. We had a quadratic problem. We needed to find whether it opens up or down. Well, A is positive. It opens up. So it's going to look like that. And the equation of the axis of symmetry, which is the x value of the vertex, sometimes we call that H, is minus B over 2A, which is, B is minus 4, so it's minus 4 over 2A, which is 2. So the X value of the vertex is 2. And so the vertex, you just have to plug in 2 into the equation, and you get y equal 2 squared minus 4 times 2 plus 3. 4 minus 8 plus 3. All that adds up to minus 1. So the y value of the vertex is minus 1. And the y-intercept, you just plug in x equals 0, and you get 3. So the y-intercept is 0 and 3. And then one problem, I think maybe 65% could not get this one, and I'm trying to figure out why, because all they had to do was plug in 5 to find out how high this object is after being shot from a cannon. We just plug in. And if you do that, you get 980. And then finding the zeros of quadratic, we haven't emphasized factoring, but you can factor this into x minus 11, x minus 3, and set it equal to 0, and you get x equal 11, x equal 3. But if you didn't remember how to factor, you could always use the quadratic formula, which will always work. So minus b is minus 14, plus or minus the square root of b squared, which is minus 14 squared, minus 4 times a, which is 1 times c, which is 33, all over 2. 2a is 2. So this will be 14 plus or minus, if you calculate this, it's the square root of 64 over 2, which is 14 plus or minus 8 over 2. And if you do that, you get either 11 or 3. Now, another thing I was a little surprised about was exponential decay or exponential growth. You'll recall that you have an equation y equals some initial amount, say, call it A0 times 1 plus r to the t or x, it doesn't really matter, where r is equal to the rate of change. And if r can be positive or negative, if it's negative, 1 plus r is less than 1. Okay, Now, the multiplier is called 1 plus R. And if 1 plus R is less than 1, it decays. And if 1 plus R is more than 1, it increases. Now, obviously, 1 plus R is less than 1. And I think you probably know that if every time you multiply something by 0.63, it goes down in value. So as X increases, the more times you multiply, it decays. So this was X. This particular student said it was exponential growth, and a number of students said that and didn't recognize that that was decay. And I think one of the last problems was, this may not have been your problem. You may have had different numbers, but it's a vehicle purchase for $27,500. Depreciates at 6%. That means that R is minus 0.06. So 1 plus R is equal to 0.94. So the equation would be 0.94, and for 12 years, you do this on your calculator and you get $13,088 is how much it's worth after it depreciates for 12 years. Okay. Does anybody have any questions about anything? I'm not sure who all is here.
No.
Let's see who all is. It's just us two, us three. Yeah, Charisma and Miranda. I hope everybody will be watching this. The section that we've been looking at this week starts off with probability. And sometimes this is the most difficult one for students. So if you have any questions, please ask them or interrupt me. I'm not going to go over the entire lecture on probability, but we're going to hit some highlights. The results of an experiment is called an outcome. An event is any particular outcome or group of outcomes. A simple event is an event that cannot be broken down further, and the sample space is a set of all possible simple events. So as you work probability problems, you're going to need to break it down and think about what all the possibilities are, and then all the events that are favorable to the outcome you're looking for. I'm sure you understand this, the probability that an event occurs is a number of possible outcomes corresponding to the event divided by the total number of equally likely outcomes. Now, the complement of an event is the event that E does not happen. And sometimes we use E with a bar over it to stand for the complement of an event, means that it doesn't happen. And we could compute the probability of the complement by saying that the probability the event doesn't happen is 1 minus the probability that it does happen. I had a student ask me why this was so, and the way I answered that was, suppose the probability of rain tomorrow is equal to 20%, which is really 0.2. what's the probability of no rain? If I tell you a 20% chance of raining, what's the probability of it not raining? What's the answer?
80%.
80%. I think that's pretty obvious, which is really 1 minus the probability that it will rain. So this is a concept that you need to understand. And then you get to odds. Odds is what you get into when you talk about gambling on a sporting event or just about anything. Sort of interesting. I studied statistics and probability at Georgia Tech. Probably had 4 or 5 courses on it. And we never really got into odds. Would you believe that? We were looking at into all kinds of other probabilities. And of course, you probably heard of odds about whether or not the Nats are going to win the World Series. But anyway, the definition is pretty straightforward. It's a ratio of the probability that a particular event will occur to the probability that it will not occur. And we'll always express the odds in simplest forms. So we calculate the probability of the event and divide it by the probability that the event will not occur. And then the odds against an event is a ratio of the probability it won't occur to the probability it will. So if the odds were for an event were 5 to 1, the odds against it would be 1 to 5. Another important thing is independent events. They're independent if the probability of event B occurring is the same whether or not event A occurs. And then if the probability that both A and B occur is simply, if they're independent, just multiply the probability of A times the probability of B. All of this is in the video. Now, sometimes you can have an event A and an event B that will overlap. And if you wanted to find the probability that either A or B will happen, you're going to add the probability of A, which is represented in blue here, and then you're going to add the probability of B. Now that's green, by the way. I'm not colorblind. And probability of B, which is in blue here. And you need to subtract off. Notice when we added those two, we double counted this. So we need to subtract off the overlapping, which is probability of A and B occurring. Now they're mutually exclusive if they do not share any common outcomes. So if you had event A and event B that didn't overlap, they're mutually exclusive. Now, I'm just going to show one example here. You've got a drawer that has 10 pairs of socks, 6 of which are white, and 7 t-shirts, 3 of which are white. If you just reach in and randomly grab a pair of socks and a t-shirt, what's the probability that you have at least one white one? Okay, well, let's set up, let A be the event of drawing a white sock and B be the event of drawing a white t-shirt. Now, it's pretty obvious that the probability of drawing a white sock is going to be 6 out of 10. the probability of drawing a white t-shirt is going to be 3 out of 7. Then the probability of A or B getting a white sock or a white t-shirt is adding these two together and then calculating the probability that you get a white sock and then a white t-shirt. That would be the probability of A times the probability of B. That's subtracting out the overlapping part. So you add the 6/10, the 3/7, and subtract out the probability of A times the probability of B, and do the math, and you get 72/7 minus 18/70 minus 18/70 equals 54/70, which is 27/35. Now, sometimes two events are not independent. And if you want to find that both A and B occur, you're going to have to multiply the probability that A occurs times the probability of B occurred given what happened with A, given that A occurred. Let's just do an example here. Suppose you've got a card deck, 52 cards, and you draw one card, don't replace. And then draw a second card. What's the probability that both are kings? Okay. Well, that's going to be the probability of A, the first card being a king. There are 4 kings in the deck. So the probability of that is 4 out of 12. I'm sorry, 4 out of 52. Times the probability that your second card is a king, given that your first card was a king. Well, if the first card was a king, you've only got 3 kings left. So the probability out of the 51 cards that are left that you get another king is 3 out of 51. So that's equal to 1 out of 13 times 3 out of 51. And so, let me get my calculator out. $13 times 51 is 663. So that's going to be 3 out of 663. Now, the last video in this week's set of videos is counting and probability. And a fundamental counting principle is if there are M items in one category and N items in another category, then the total number of available choices is M times N. And you can extend it to more than 2 categories as well. Simple definition, the factorial of a non-negative integer n is the product of all the possible integers less than or equal to n. And that's pretty easy to do. 6 factorial, for instance, is 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. You probably will not have to do a lot of factorials because what you're really going to be using is to get combinations. And here's a combination formula. We say that there are combination of n things taken r at the time is called, it is denoted by C in R. Now, when I was in school, we did it this way. Combinations of n things taken R at a time without replacement, when order does not matter. Now, we do not have to actually do all the factorial, because if you got the calculator here, I'm going to show you how to calculate combinations of n things taken r at the time. Let's say we want to do combination. Suppose we had 10 people, and want to form a committee of 5. So we want to take these 10 people and form a committee of 5 from those 10 people. The number of ways you can do that is combination of 10 things, taking 5 at the time. And we will do that with the calculator. And the way to do that is to first put in your 10 and hit probability here, PRB. And you've got a choice. Here's your n things taken r at the time, your combinations. By the way, if you want to get factorial, you would just hit that. And then hit that, and then put in 5 and hit enter. And there are 252 possible ways to form a committee of 5 people if you have 10 choices. Now, you could sit down and write all the possibilities, but that would take you quite a long time. But thank goodness we have some good mathematics to help us do this. An example is you got a United States Senate Appropriations Committee consists of 29 members, and we want to form a subcommittee of the Appropriations Committee consisting of 19. So how many ways can you do that? And that's a combination of 29 things taken 19 at a time. And you don't have to worry with the factorial. All you do is plug it in, 29, 19. Excuse me, I forgot to turn my phone off. Okay. combination 29 taken 19 at the time, and that is 20,030,010. That's how many different committees you could form from 29 people if the committee size was 19. So you have to have a calculator to do this. How many people play the state lottery? If you want to find the probability that you're going to win if you buy one ticket and you have a Powerball and there are 48 balls numbered 1 through 48, and you're going to pick 6 and you win $1 million if they get your number. The total number of ways to pick 6 balls out of 48 is a combination of 48 things, taking 6 at the time. I'm not going to stop and put it in the calculator, but if you do it, you'll get 12,271,512. So the probability of your one ticket winning is this small, basically 1 in 12 million. Now, I have put a practice test up on the website. So when you get ready for test 4, these are some of the problems that are going to be on there. And why don't we work a few? I'm not going to work all of them. We've got 2 fair-sided dice. They're rolled. What's the probability that the sum of the 2 numbers on the dice is greater than 10? Well, I haven't written all this down yet, so I'm going to work this problem. You want the probability that you get sum on the die that's greater than 10. So you got dots from 1 to 6. So you could have the roll 1 and roll 2. You could have a 6 and a 6. You could have a 6 and a 5. You could have a 5 and a 6. And let's see, think about this. If one was a 5 and a 5 won't do it. So the only 3 possibilities that it's more than 10 is 3. And how many rolls? You can have 6 rolls, possibilities on the first rolls, 6 on the second. That's 36. So the probability is 3 out of 36 equal 1/12. So the answer to this is 1/12. Now, if you do the same 6-sided dice, what's the probability that the sum of the 2 numbers is not greater than 10? Well, that's probability that it's going to be 1 minus the probability it's greater than 10 is 1/12. So you subtract that from 1 and you get 11/12. Now let's do the odds. What are the odds of the sum of the 2 numbers on the dice being greater than 10? Well, it's going to be the probability that it is greater than 10 divided by the probability that it's not greater than 10, which is going to be 1/12 divided by 11/12 and that is equal to 1/11th, which is 1 to 11. So the odds against that are actually 11 to 1. Which of the following could not possibly be probabilities? Which combination? Anybody got an answer? Charisma.
I'd say A and B.
That's right. Oh, I just noted Jason Davey just joined. Charisma's left. How you doing, Jason? Jason?
He's sending out chats.
Okay. Okay. He's not speaking to us. That's all right. Well, you're correct. It is A and B. First of all, the probability can't be negative. And it can't be greater than 1. So if anybody ever tells you there's a 120% probability that you're going to win, they're full of it. Sometimes you have to think which of the following events has a probability of 0. Somebody think about this one and guess what you think is the answer.
C.
C?
Yep.
That's right, C only. You just have to use a little logic. If you lived in Portland, Oregon, where it rains so much, you might think the probability that's almost 0 that it's going to rain. But even in Portland, Oregon, there's always a chance that it will rain. You might think that you can't win the lottery if you buy one ticket. The probability is close to 0. It's more than 0, but very small. But it's not 0. However, if you know that if today is Saturday, the next day can't be Monday unless somebody renumbered the days. Sometimes you take a poll. This is how people look at elections and try to figure out who might be the winner. Group of people are asked if they had attended college. 200 responded yes. 350 responded no. What's the probability the person has chosen they attended college? Well, it's going to be 200 out of the total of 550. And you can go ahead and reduce that to a fraction or either a decimal. I think it's about 0.364. 2 marbles are drawn without replacement from a box with 3 white, 2 green, and 2 red, and 1 blue. Find the probability that both marbles are white. The probability that the first marble is white is 3 out of 8. Be sure to count your marbles correctly now. Always check your work. Now, if you don't replace that white marble, then you got to figure out what's the probability of getting a white marble out of the marbles that are left. And that would be, there are only 2 left that are white, and there are 7 total. So the total is going to be 6 out of 56, which is 3 out of 28. Now, sometimes you are given data and you're asked to look at probability. Here we have a clinical trial for an allergy drug, and we look at those who were given the drug, those who were given a placebo, those who were given no treatment, and counted how many improved, how many had no improvement, and these are the totals of everything. So what's the probability given that? What's the probability of improvement given that the patient got the allergy drug? Okay, now let's do the very first one here. What's the probability that a randomly selected person received no treatment or improved? Well, those who received no treatment are these, and those that improved are these. So that you're picking somebody at random, and so you got 145 had improvement that took the drug, plus 41 that had improvement that had no treatment, plus 59 had no improvement. So those are the ones you're looking for, divided by the total number, which is 500. And this turns out to be 0.66. Now, we have conditional probabilities. What's the probability of improvement given that the patient got the allergy drug? Well, here we're talking about the ones who got the allergy drug, and those that improved are 145 out of the total that got the allergy drug. Those are the only ones you're going to count. So that's 145 over 200. The probability of improvement given that the patient got a placebo is 85 out of 200. And the interesting thing is, if the probability of improvement given that the patient got treatment is 41 out of 100, which is the same as 82 out of 200. This is sort of interesting. I don't know whether this is realistic, that the ones that got a placebo had the same improvement as those who got no treatment. So maybe that makes sense, okay? But notice, looks like the drug works because 145 out of 200 got an improvement if they actually got the allergy drug. Okay, number 15. How many different 4-topping pizzas can be made if there are 13 individual toppings to choose from? assume that no topping is used more than once and that the order of the toppings on the pizza is unimportant. Well, this would be the combination of 13 things taken 4 at the time. And if you put this in your calculator, you'll do 13 probability combinations of anything taken R at the time. And we're talking about 4. Hit enter, and we get 715. So that's the number of possible pizza you could make if you have 13 toppings and you want to have a 4-topping pizza. There are 5 members on a board of directors. If they must elect a chairperson, a secretary, and a treasurer, how many different slates of candidates are possible? Well, you got 5 members on the board. You got to have, when you select a chairperson, there are 5 possibilities. When you, after you've selected the chairperson, there are 4 choices for a secretary. And after you've done that, there are 3 choices for treasurer. And that adds up to 60. The poker hand consists of 5 cards dealt from an ordinary deck of 52 playing cards. How many different hands are there? Consisting of 4 hearts and 1 spade. Well, there are 13 hearts in a deck. And the way you can get the number of combinations of getting 4 hearts out of 13 hearts are a combination of 13 taken 4 at the time. And if we do that, we get $13 probability combination of n things taken R at the time. Hit enter and put in 4, and you get 715. And you have 13 spades. And you then want to calculate the combination of 13 spades taken 1 at a time, because you only need 1. Well, that's going to be, put it in your calculator, will be 13. So the total possibilities would be 715 times 13 equals 92.95. And that is the meeting for today. Everybody have a good evening.